October23, this is the second part of this, and we're going to be graphing polynomials.
I know.
And when we get to graphing the polynomials, what we're looking at doing is we're going to use our calculators a little bit, but we're also going to look at what's called end behavior. End behavior is what's happening to a graph as it's tailing off into the sunset, shall we say. What happens to it in the very end as it's approaching infinity? For example, if I just have a regular old boring parabola, and I should probably draw some smart board so you can see it. If I draw a regular old boring parabola, if I draw that without giving you any function of it at all, could you tell me a little bit about that? What could you tell me? It's up like a cup, therefore it's what? It's an x squared, and it's positive. So we know right off the bat it's a positive function because it's up like a cup. It's an x squared term because it looks like a parabola. Yes, ma'am?
It goes on forever and
it goes on forever because they're never going to meet because I have the little arrows on there showing the tail stuff. Now, here's what happens. When I'm talking about this thing called end behavior, bless you. End behavior is what's happening at the tails. Now, does everybody agree that this is my x values that are positive, and these are my x values that are negative? So here's how we say this. As x approaches positive infinity, as the values of x are getting larger and larger and larger, what's happening to this graph? What is f of x looking like? What is it approaching? Infinity. Our function here is an f of x equals x squared. We kind of just determined that from the graph. I don't know what the actual function itself is, but I know that it's some parabola. Parabolas have an x squared component to them. Y equals x squared, for example. In this case here, I'm saying as the values of x are getting larger and larger and larger, what's happening to the values of y? They're also getting larger, aren't they? Remember how we said the other day that f of x is synonymous with x equals, or excuse me, y equals?
Yeah.
So what we do here is, as x is approaching positive infinity, in this graph, the tail here is getting larger and larger and larger. It's also approaching positive infinity. So as x approaches infinity, f of x is approaching positive infinity as well. Okay.
If it were to be down from, would it be negative infinity?
Correct. Correct. As x is getting larger, it's approaching negative infinity. Yes, ma'am?
So f of x is tails?
Yeah.
Is it like
F of x.
tails?
God bless you.
Like how would you find that?
God bless you. You're not finding the actual value. You're finding what is it approaching? What does it appear to be getting closer and closer to? Okay. The f of x, remember, is synonymous with saying y equals. So as x is getting bigger, y is getting bigger. Or if x is getting smaller, y is getting smaller, or so on, depending upon what the graph looks like. If I'm going the other way with this equation, if I'm looking at the other side, as x is approaching negative infinity, so as x is getting smaller and smaller and smaller, what is f of x doing? It's getting bigger and bigger and bigger. See how the graph is getting larger and larger and larger as it's going that way?
Wait, what is it graph?
The x
I see it kind of go off.
What's that?
squared. X equals x squared.
This is kind of what this function is. That's all that is. It's just some equation. I don't know what it is. As x is getting smaller, what's the graph doing? It's still increasing, but it's just increasing on this side. These are still getting larger and larger. So as x is getting smaller, f of x is approaching positive infinity as well. Okay? Depending upon what the curves are doing. You're looking at this in terms of infinity. As things are getting larger, what's the graph doing? Is it increasing or is it decreasing? That's basically all it is. Okay? That's all this means. Let me show you another quick example with the curve. I've got my grid.
Oh, that's great.
Some graph. I don't know what it looks like, it's just some graph. And what I do here is, I write it out two different ways. As x is approaching positive infinity, f of x is approaching something. As x is approaching negative infinity, f of x is also approaching something. So, as the x values get bigger and bigger and bigger, what's the graph doing? Is it going up or down? It's going up. So what is it approaching?
Infinity.
Positive infinity. In this graph, as x gets smaller and smaller and smaller, where's it going?
Down.
So what's it approaching?
Negative infinity.
Negative infinity. It's nothing more than looking at the graph and remembering, as the x values get bigger, what's the graph doing? As the x values get smaller, what's the graph doing? Yes, ma'am?
But if that were up and then down, how do you know it's not going to go back up?
You would see, you have to go off of the arrow. The arrow shows that it's continuously going that direction. Okay. The arrow will show that it's continuously going that way. Yes, ma'am?
I'm confused. Are you label like certain parts of it that are going down?
No, I'm looking at it in terms of general. This is your x values as they're getting positive x values, and they're getting larger and larger and larger going this way, right? That's all I'm looking at. I'm just looking at where are these tails pointing. That tail's pointed up, the other tail's pointed down. That's all I'm looking at. Okay. I'm not looking at what we call the local areas yet. We will. And those two curves there, do you see how there's a local area that has a maximum and a local area that has a minimum? We will be able to find those in these curves. Maybe not today, but we will. Okay. Let's see. I want to do this one. Yes, that's an actual function. Eventually.
For now,
Eventually.
for now,
We're just looking at a rough idea. I want you guys to understand what it means to, just as things are approaching infinity and negative infinity. In a couple of minutes, I'll start to show you how you can do some numerical values. Okay. All I'm doing here is I'm looking at the end behavior. That's all I'm looking at. What's happened at the ends. So in this case, on this side, as x is approaching negative infinity, what is f of x approaching? Very good. Oops, negative 8. What is f of x? Remember, it's the same thing as y equals. As x is getting smaller, y is getting smaller. Remember, your x and your f of x are ordered pairs. Okay? X is your x value, your f of x is your y value. When we did synthetic substitution the other day, when you substitute in where it said x equals 2, you go through the substitution, you were creating ordered pairs. It's a very fast way to do ordered pairs. Yes, ma'am?
Those two are both going
Nope. It's just on this side, since as x is getting larger, f of x is just getting smaller.
So it's not the way the arrows are going, it's like the way,
It is the way the arrows are going.
I'm so confused. Is it because the arrows are going down that's negative,
Yeah.
or because it's going to the left that it's negative?
Down. Because remember, this right here,
Okay.
this is f of x.
So that's going down, so why isn't it positive?
What do you mean it's positive? These are going down. It's going downward. What is this doing as this is getting larger? This is getting smaller.
Oh.
Yeah, x is getting larger. It is.
This is okay.
Because isn't this the right side of x where it's getting larger?
Yeah.
So basically, this ordered pair here is 2 and -3. This one is 4 and -6. This one is 6 and -10. The x value is getting larger, the y value is getting smaller. That's what that is representing, without putting in numbers. I'm just looking at the graph. Okay? What end behavior does is just showing you what's happening at the tails of a function. Okay? That's what end behavior does. Now, your book does this a little bit differently. Your book writes it backwards. So when you see this in your book puts f of x first and then x. I will never, ever, ever, never do that. Because like I've been telling you guys before, f of x and x are ordered pairs. What comes first in ordered pairs? X. What they're doing is they're putting the k in front of the h. Don't do that. So remember, it's x approaches and then f of x. We always write it x first, then to the f of x. Does that make sense? Your book does it backwards. So I just want to forewarn you on that. So what I want to do here is take a second and show you how these things look, when we use our calculator. Okay? So take a second, let's get our calculators out. Let's put in a couple of these functions just so you get the idea of what they're looking like. There we go. What I want you to do is I want you to put in x to the 5th. I want you to put in the curve x to the 5th. Y equals x to the 5th. And just go to your graph.
Why makes the papers?
This is right next to the green button. Right next to the alpha button.
Yeah.
And you get a quick curve. Okay? So if I'm looking at x to the 5th, as x is getting larger, what is f of x doing? It's getting larger as well. As x is getting smaller, what is f of x doing? Getting smaller, it is.
My graph doesn't have like that.
Put in x to the 5th.
Do you do x to the 5th or x to 5?
I did x to the
What's your window at?
x.
There's your problem.
Yeah.
Go to a negative 10 by 10. Go a 10 by 10 window, okay? That helps visualize it a little bit. Now, what I want to do here real quick is go back to your y equals, and I want to do the y equals negative x to the 5th. And do you guys know how to turn on and off graphs? Okay. Right now, let me show you this. If you hit graph, you'll have two curves. You'll see two of them. You don't want to see both of them at the same time. Oh, that means you overrode it, that's why. If you still had two, if you have in your y equals both graphs, both functions there, x to the 5th and negative x to the 5th, what you can do to turn one of them on and off is highlight where the where your equal symbol is and hit enter. And it'll turn that one off for the time being, so you can only see one. It's a nice little shortcut. Sometimes if you're doing multiple graphs, you need to look at them. Now, if I'm looking at this one, what's different when it's negative x to the 5th? It's flipped, right? It's flipped. Okay. Let's look at x to the 6th. Let's change these out to x to the 6th. X to the 6th is an even power. Again, it's more shaped. Not all of these evens will always be looking like a parabola. There's reason why they're doing that right now, because there's no other factors tacked on there, there's no one term. But notice how if you're positive and you're having even exponent, both tails are up. What do you think is going to happen if you're negative within both be
Go down.
down? It matches, what's that?
With the negative exponent or the positive exponent?
With positive exponents. These will all be dealing with positive exponents. Okay. It matches the same idea of when you guys did quadratics. If the leading term coefficient was positive, they were up like a cup. If they were negative, they were down like a frown. It kind of does the same thing when you're dealing with even and odd exponents. Okay? There's a nice little shortcut that happens. There's one thing that happens when you have the difference between an even and an odd exponent. If you have an even exponent and your leading coefficient is positive, if you have an even exponent and your leading term coefficient is positive, that means your tails are both going to be f of x will be approaching positive and f of x will be approaching negative. It's up like a cup. Think up like a cup. Think that. If x is approaching positive and x is approaching negative. Okay. I just didn't write it all out. Think of it as up like a cup. Does that make sense? Correct. Both of them will be both tails will be approaching positive infinity. And if it was the leading term coefficient was negative, both tails will be approaching negative infinity. Oh, did I write that? Sorry, I meant. Now I know what you meant. Sorry. Okay. Think of it as when you have an even exponent, they're both gonna be. It's gonna be up like a cup.
Oh, yeah.
And if you have your first term is negative, they'll be down like a frown. Okay? It's very easy to remember that. Okay? It's very easy to remember that. If the leading is negative, then it's down like a frown. Just like you did with parabolas. They're both facing downwards, so they're both going towards negative infinity for f of x. God bless you.
Thanks.
When you get into your odd functions then, this is where it gets to be kind of fun. When you have an odd exponent and your leading term is positive, it's going to do this. You're staying alive.
Like a snake.
All right?
Like when you try
Yeah, you're trying to be yes, you're trying to play snake. You ever play the game Snafu on Intellivision? No? It's a cool game. It's an awesome game.
Never even heard of it.
It's awesome. It's from like 1979. Anyway, if the leading term is positive, the curve's going to look somewhat similar to that. If its leading term's negative, what do you think it's going to do?
The other way.
It's going to go the other way. If negative, it'll do that. So your tails will be going the other way. So your tails here, as x is getting smaller and smaller and smaller, f of x is getting smaller. As x is getting bigger, f of x is getting bigger. And then it's just the other way around. That's what's nice with polynomials, is that all of their graphs may not look identical, but their end behavior has the same patterns. All right? Yes, ma'am?
If the leading coefficient is like 1, would it be flat?
If it's 1, is it positive or negative?
Wait, this positive, but like that's an odd exponent, so So would it be that way, or would it be like straight?
Okay, yes, we're talking about polynomial, yes. Then you're talking linear. Then you would go through your linear stuff, yeah. And I'm looking at curves mainly, but yeah, the linear stuff, you're thinking slopes now. Okay. Now, what's nice about this is that you should absolutely, positively, never, ever, ever, never, ever, never get one of these types of questions wrong. Because why? That, and you have a calculator that can graph these things.
But what if it's on the non?
And you're to be here.
Then it's over.
Right.
If it's possible to mix it half base, there's anything that makes this half base and on the other side.
So you're saying
Oh, I get it now why you did that.
that is a negative dance, isn't it? This is bad. I gotta make up for a day. You guys missed out on bad jokes.
Oh, it's like you're just.
You were just heartbroken, I know.
I didn't like that summer.
I don't know who it was. All I know is they had a different sub for me every hour, so, oh well. Well, if you guys would just, do your work.
Yeah.
Okay.
She was like, no cell phones, no nothing, we need them books.
Here's what I'd like you to do. What I'd like to do is go into the graphing calculator, and I want to look at a couple of these functions and help describe what the end behavior looks like. The first one I'm going to look at is x to the third minus 5x. So I'm going to go to my calculator. Y equals, clear it out, x to the third minus 5x. Remember when you type in an exponent, you have to hit the right button to drop out of the superscript so you can put in the minus sign. Okay? That's what that means when you have the exponent. It's called superscript as opposed to subscript, which is below. Very excited, I can see.
I'm so confused.
So confused, all you do is press buttons. X cubed.
Darn it.
Don't drive angry. Now, does everybody...
She really likes Nicholas Cage. So that was like.
Don't Drive Angry was from it's Bill Murray in...
Drive Angry is a movie with Nicholas Cage,
Oh.
which makes her really happy.
What? Mr. Murphy, my calculator's being stupid.
It's not the calculator.
I typed it incorrectly, but then it says invalid.
Oh, dude, no. And Miss Favor playing close. She's a nobody. I wasn't anybody.
What is
Not.
You're nobody.
That's the same thing as saying. Yeah, but I guess what?
When did you are?
Well, you had to feel real good about yourself, didn't you?
Yeah.
You nobody.
There
There you go. I don't know why I did that. Now, what can you guys tell me? As x is getting smaller, what is f of x doing? As x is getting larger, what is f of x doing?
Going up.
Okay. Now, look at the next one. Without graphing this, without using our calculator, it's a negative. What's the exponent? It's odd. It's negative and odd. What is this going to look like?
Negative.
Like the. No. That's me like.
Like this.
Come up and show it. Go for it. You gotta let. I wish.
No, other way.
She's right.
Dang it.
She's right. Because it's gonna go.
I
Did
was
you just
thinking
flip it off? I thought you did. I was like, wow, that's awesome.
Wow.
Now, in this case, she's right. It's going to look I don't care what it looks like, but now I know that since it's an odd exponent, it's got a negative coefficient, it's got to be doing that funky looking thing. Yes, ma'am.
Are you looking at the first one or the second one?
Second?
No, I mean like negative x to the fifth or.
Yeah.
Look at the leading code.
I know.
Yes, I'm looking at the leading coefficient. Leading coefficient
So
here.
not negative 3x to the fifth.
Nope, I don't care. I'm looking at the first term. This is a fifth degree polynomial. All right? This next one, x to the fourth. It's x to the fourth. It's even. Touchdown. I don't know what it's going to look like. It's just
That's good. That's good.
Is it a
Or you could be like rugby where they go,
I don't have ever seen that.
you've ever seen that on TV? They kind of, they walk up to it and kind of go,
Like, no, like I haven't watched it. Yeah, I never watched
I never have either, so.
How do you know that?
No, we're not there yet. We're not there yet. There's one other little bit here.
Of course there is.
Of course there is. There's always more, of course. What I want to do is I want to look at that one. Negative x to the 8th plus 9x to the 5th minus 2x to the 4th. Negative x, x to the 8th plus, oops. Okay. Yep.
It's just simple.
Which
Well,
Okay.
Well,
Now,
Weird line.
here's what's happening. This one comes up, it does that.
Okay, that's what it's.
Okay? Okay. What's happened at the tails?
It's still down.
It's still behind the frown, isn't it?
Yeah.
It's just funky looking.
Problems will have to drop.
Yes, you should make some.
What that's what I'm looking at right now. That's pretty much what I'm looking at right now. Eventually, we are going to be able to not use the graphing calculator, and we're going to graph that by hand without a calculator. Okay.
because it goes down, it goes up.
We know that it's an 8. We know that there's an 8th degree term, so it's a negative coefficient. So I know the tails are going to do that. It's all that junk in the middle. I have no flipping clue what's going on. But there's things we can do. If you have this function, negative x to the 8th plus 9x to the 5th minus 2x to the 4th, and let's say I set it equal to 0. You know where I'm going, don't you? Where am I going? I'm not going to go cry. I'm not going to go to sleep. I'm going to find points, which means I'm going to want to, what's that nasty F word you guys don't like? Factor. What's the GCF?
9, not.
Negative 1.
X to the 4th.
X. Oh.
Here's what I'm going to do. Here's what I'm going to do. I'm going to factor out a negative x to the 4th. Negative 1 x to the 4th.
Why is it X to the 4th?
What's that?
Why is it X to the 4th?
See how they have x to the 8th, x to the 5th, x to the 4th? What do they all have in common? X to the 4th. It's a GCF.
But 5 is divisible by 2.
It's not divisible, but how many?
That's not how, that's not how.
2.
Right. This is x to the 4th plus 9x minus, minus 9x plus 2.
We took our X.
Yeah, x to the 4th.
So wouldn't it be
Oh!
X to the 1?
Right.
Is it?
Okay. We're eventually going to be able to do this because now you have two terms, don't you?
Yeah.
Set them both equal to 0, so you know you have 1 0 at what?
0.
I have a 0 at 0.
Wait, how did you know that?
Because I set that first term equal to 0. What makes x 0? 0.
What did you say? What?
Remember when you did this, when you had x and you had x minus 2? You set them both equal to 0? You do that?
But what if
Nothing changes there.
x to the fourth equals 0?
Yeah, so what's x then? 0.
Well,
That's
you
all.
only wrote x.
Well, I know, but I'm just saying, I have 1 0 is going to be at 0. I know that for certain. The other one, it's x to the 4th minus 9x plus 2 equals 0, which means I have to find those other zeros. Which means I have to find a way to do that. Bless you. Remember that?
Yeah.
Synthetic division allows you to find zeros of polynomial functions.
That's fun.
It is pretty sweet. It's very, I get all excited about, woo, polynomials, yay! It's a very easy process to do.
Is division like you do the same thing like you subtract?
Bless you.
You like add things and then multiply, but it's multiply, do you divide or is it like
It's a whole different thing. We'll get there, okay? Well, it's actually, you know what, in honesty, synthetic division is a synthetic substitution, we just call it something
How are you
different.
in there at 8?
Yes, ma'am.
What are you putting out there?
Not worried about it. We're getting there. Can you tell me the details here, though? That's all I'm looking at today. I'm telling you where we're headed. So tonight, when you get to the homework stuff, here's the way I would like you to write this. When they're asking you about what's happening at the tails, what's happening as f of x's and all that, make sure you write it as x approaches negative infinity, f of x is approaching, in this example, was approaching negative infinity. As x is approaching positive infinity, you write f of x is also approaching positive infinity. That's what it looks like. Sorry. I was thinking of the other problem. Both tails are pointing downward. All right? Let me give you a few of these to do tonight. I don't want... We're going to start talking more and more about what's called localized maximums and minimums. We'll start talking more about how you find all the rest of these zeros. But we start with the tail ends and just go from there.
Sounds like someone
Iron? Is it iron? Oh, like ironic. Oh, where are we at here?
I'm just kidding.
This is still section. Four evens, and then give it a shot. Okay.
Why? You said a few.
These here are just what's happening at the tails. The last 5 or 6 of them are looking at using your window functions and using your table functions in your calculator to try and solve a couple of problems. I have no doubt that you'll be able to do it on your own. Okay? We'll talk about how you get into doing the actual real graphing of everything later. I'm not going to worry about graphing them yet. So you guys have a table, you can just press a button, so that's all this stuff. All right? Give those a shot, and we'll go from there.